Hello children, and welcome all of you to the class of mathematics. In today's video lesson we are going to begin with new chapter. This is chapter number 2, polynomials. Let us first understand which particular part of the topic is being deleted for the CBSE board examination 2020-21. So from the chapter, this particular part, that is the division algorithm for polynomials, this particular part is being deleted. Please note this is 2.4 division algorithm for the polynomials. And based on this, there are certain solved examples which are given, which is solved example number 6, 7, 8 and 9, which is on page number 33, 34, 35 and 36. These solved examples are also not there. Based on this topic, we have exercise 2.3. So exercise 2.3 is also not there for the board examination. And from exercise 2.4, which is an optional exercise, from this exercise, question number 4 and question number 5 are based on this particular topic. So these two questions are also not there. So please keep a note of this particular part which is being deleted from the chapter. Now let's begin with what we have in the chapter, and we will begin with what is the meaning of polynomials first. All of us have studied about the algebraic expressions in the previous classes. So an expression, I can say an algebraic expression which contains one or more terms with non-zero coefficients is called a polynomial. A polynomial can have any number of terms, and that is the reason it's given the name as poly. Poly means many. So a polynomial can have any number of terms, and the exponent of the variable is a whole number. This particular thing is very important, that the power of the variable or the exponent of the variable has to be a whole number. So just see this example. 5x cube plus 3x plus 1 is an example of a polynomial. It is an algebraic expression also. Let's have a look at the second example. 2x plus 3 root x is an algebraic expression, but it is not a polynomial. Can you guess the reason for this? It's because the exponent on x, 3 root x, when you see, so the exponent of x is 1 by 2 here, which is not a whole number, and that is why it is not a polynomial. So a very important condition for an algebraic expression to be a polynomial is the exponent or the power of variable has to be a whole number. Next is the degree of a polynomial. So the highest power of the variable in a polynomial is called the degree of polynomial. Let's have an example. The degree of this polynomial x squared plus 2x plus 3 is 2. Highest power of the variable is 2 here, and so we can say that 2 is the degree of this polynomial. Alright. Now let's understand the types of polynomial. So linear polynomial, a polynomial of degree 1 is called as linear polynomial. 2x plus 1 is an example of a linear polynomial because the degree of the variable is 1 here. Second type of a polynomial is quadratic polynomial. Children, we have learnt about quadratic equations, and you all are aware that when the power of the variable is 2, we call that equation as a quadratic equation. Similarly, in an algebraic expression, if the power of the variable is 2, then the polynomial can be expressed in the form ax squared plus bx plus c, where a is not equal to 0 and a, b, c are constant, and such polynomials are quadratic polynomials. So 3x squared plus 8x plus 5 is an example of quadratic polynomial because the power of the variable is 2. Then the next type is cubic polynomial. So the name itself suggests cubic. Cubic means power is 3. So a polynomial having highest degree of the variable is 3 is called a cubic polynomial. So in general, a cubic polynomial can be expressed in the form ax cube plus bx square plus cx plus d, where a is not equal to 0 and a, b, c and d are constants. So the example of cubic polynomial is 2x cube plus 5x square plus 9x plus 15. So these are the 3 types of the polynomial. Alright. Now let's understand what is the meaning of zeros of a polynomial. So the value of the variable for which the polynomial becomes 0 is called the zeros of the polynomial. Let's take an example so that you will get good understanding of the meaning of zeros of a polynomial. So consider a polynomial p of x is equal to x square minus 3x plus 2. This is a quadratic polynomial because the degree of the variable is 2. Highest degree, in fact, I can say is 2. Now suppose if I substitute x is equal to 1 in the given polynomial, then the value of p of x will be, since we have taken x is equal to 1, so we can write p of 1 is equal to 1 square minus 3 plus 2. So what we get? We get minus 2 plus 2, and minus 2 plus 2 is equal to 0. So since p of x is equal to 0 at x is equal to 1, we can say that 1 is the 0 of the polynomial x square minus 3x plus 2. So this is how we can find out zeros of the given polynomial. Alright, I'll repeat once again. Zeros of the polynomial or 0 of a particular polynomial is the value of the variable for which the polynomial becomes 0. Alright, let's move ahead. Now let's understand what is the geometrical meaning of zeros of a polynomial. Geometrical meaning means graphically what is the meaning of zeros of the polynomial. So y is equal to 2x plus 3 is a linear polynomial. We will consider this as a linear polynomial. Now since geometrically we need to understand the zeros of the polynomial, we have to draw the graph of this linear polynomial. And you all are aware that to draw the graph we need the coordinates. So we'll draw a table. Value of x we will substitute so that we will get the value of y. So here you can see the table. When x is equal to minus 2, we get the value of y as minus 1. When x is equal to 2, the value of y is 7. Now suppose if I draw the graph of this particular values for x and y. Our first coordinate is minus 2, minus 1. So we'll mark it like this. Then 2, 7. And if I draw a line passing through these 2 points, it is a straight line because it is a linear polynomial. Please see this point where the graph intersects x-axis. That point is minus 1.5. So at minus 1.5, 0, the line intersects x-axis, and if I put x is equal to minus 1.5 in the given polynomial, I'll get the value of the polynomial as 0. So we can conclude that the 0 of a polynomial 2x plus 3 is the x coordinate of the point where the graph of y is equal to 2x plus 3 intersects the x-axis. So this will be always true for linear polynomial of the type y is equal to ax plus b. It will always be a straight line, and the point where this straight line intersect x-axis will always be the zero of a given polynomial of the type y is equal to ax plus b. Alright, so keep this in mind. Let's move ahead. Now let's consider a quadratic polynomial. And you all are aware that quadratic polynomial is a polynomial wherein the highest power of the variable is 2. So we have considered a polynomial as x square minus 3x minus 4. Let us see what the graph of y is equal to x square minus 3x minus 4 looks like. So let us find out some values of y is equal to x square minus 3x minus 4 corresponding to a few values for x as given in the table. In short, we will again draw a table for finding the coordinates because we have to draw the graph for the given quadratic polynomial. So the table will be like this. We have written the values for x there, and that values of x we have to substitute into the given polynomial, that is y is equal to x square minus 3x minus 4. So when we put x is equal to minus 2, value of y is 6. When x is equal to minus 1, value of y is 0. When x is equal to 0, value of y is minus 4. And this way we have calculated few values for the given quadratic polynomial. Let us draw the graph now for the values which we have got. So our first coordinate is minus 2, 6, which is here. Then minus 1, 0, it is here. Then 0, minus 4. Then 1, minus 6. After that 2 minus 6 is here. Then 3 minus 4. After that 4, 0. And then 5, 6. So we have got the points like this. Let's now draw the graph passing through all these points. You will observe that the graph looks like this. Can you just mark these 2 points? These are the 2 points where the graph intersects x-axis. And I told you that if the polynomial is of the type y is equal to x square minus 3x minus 4, then the place or the points where the graph intersect x-axis will be the zeros of the given polynomial. In quadratic polynomial, we understood that the graph intersects x-axis at 2 points, so the quadratic polynomial will have 2 zeros. Alright, so just see this. We can make out that the graph intersects x-axis at minus 1 and 4. So I can say that minus 1 and 4 are the zeros of the given quadratic polynomial. Also note from the graph that minus 1 and 4 are the x coordinates of the points where the graph of y is equal to x square minus 3x minus 4 intersects x-axis. Alright, thus we can conclude that the zeros of quadratic polynomial x square minus 3x minus 4 are the x coordinates of the points where the graph of y is equal to x square minus 3x minus 4 intersects x-axis. So keep this in mind. If it is a linear graph, it will have 1 0. If it is a quadratic polynomial, then it will have 2 zeros. So the number of points where the graph intersects x-axis, that will be the zeros of the polynomial. Alright, let us move ahead. Now see, for the quadratic polynomial, we will understand different cases. Now when the graph cuts x-axis at 2 points, then the 2 points are the 2 zeros of the quadratic polynomial. This is what we understood from the previous slide. Have a look at this. This is also a quadratic polynomial because the graph has intersected x-axis at 2 different points, that is at 0 and at x is equal to 4. Alright, but if you observe there, the graph opens up in the upward direction. Now when the graph opens up in the upward direction, it means that the value of a is greater than 0. A in the sense, you know that the standard form of quadratic polynomial is ax square plus bx plus c. So when a is greater than 0, the graph opens upward. Have a look at the second graph. You can just see here that the graph opens downward. Now when the graph opens downward, its meaning is a is less than 0. So this is a quadratic polynomial which has 2 zeros, that is 0 and x is equal to 4. But here value of a is less than 0. It is for the graph y is equal to minus x square plus 4x. Alright, and the previous graph is for the equation y is equal to plus x square minus 4x. So in the first case a is greater than 0 and in the second case a is less than 0. Let's understand the second case. When the graph cuts x-axis at only one point, then that particular point is the 0 of that quadratic polynomial and the equation is in the form of a perfect square. Have a look at this graph. Can you just make out that the graph intersects x-axis at only one point? That point is the origin of the graph. Now if the graph looks like this, that means the given quadratic polynomial will be of the type of a perfect square. So this is the graph of quadratic polynomial y is equal to x square. Alright, can you just see the next graph now? Here the graph opens downward. This shows that the graph is again for the perfect square y is equal to x square but with negative sign. Here value of a is less than 0, so the graph opens downwards. Alright, let us understand the next case. Now when the graph does not intersect x-axis at any point, that is the graph is either completely above x-axis or it is below x-axis, then the quadratic polynomial will have no zeros as it is not intersecting the x-axis at any point. Have a look at the graph. Can you just see there? The graph of a quadratic polynomial is not intersecting x-axis at any point. This indicates that this particular quadratic polynomial will not have any zeros. Alright, so this is a thumb rule for us that when you have to find out the zeros of a quadratic polynomial or any polynomial like linear polynomial or cubic polynomial, you have to find out the places on x-axis where the graph intersects. And you will observe that for the linear graph, the graph will intersect x-axis at only one point. For the quadratic polynomial, the graph will intersect at 2 points or at 1 point. For cubic polynomial, the graph will intersect x-axis at 3 points and so on. Alright children? Now based on our learning, what we have learned today, we have exercise 2.1. In exercise 2.1, you are given several graphs and the question is, how many zeros does the following graphs will have? So you have to observe the graph carefully and find out how many zeros the graphs will have. Let's take an example of the first question, the first graph, which is parallel to x-axis. You can make out that the graph doesn't intersect x-axis at any point. So what will we conclude? We will conclude that this graph has no zeros because it is not intersecting x-axis at any point. From the second graph, since it is intersecting x-axis at only one point, we will say that this graph will have 1 0. Next, if you observe this graph, it is intersecting x-axis at 3 points. These are the 3 points. So this graph will have 3 zeros. Next, in this graph, it is intersecting x-axis at 2 points. So we will say that the graph has 2 zeros. Here, if you see this fifth graph, you will observe that the graph intersects x-axis at 4 places. So this graph will have 4 zeros. In the next case, again, if you observe, the graph intersects x-axis at 3 different places. So we can say that this graph has 3 zeros. So this is how you can identify the geometrical meaning of the zeros of the polynomial. From the graph, you can find out how many zeros that particular polynomial will have. So this is all about questions from exercise 2.1. Such type of questions they may ask you for 1 mark in the examination. Please see this video once again so that the understanding will be more clear. See you all in the next video lesson with the next topic. Bye and take care.